We want to talk about the week 6 discussion, and it is on hypothesis testing, and we've been doing a lot of hypothesis testing, and that is a large part of statistics, but it's not the only thing that you do in statistics. Again, in an elementary course, it is does make up a large part of an elementary course. Um, in this particular hypothesis test, we're going to do the one-way analysis of variance. And again, we're still, testing claims about population parameters. And in this case, we're talking about means. And we have done testing of means before. We had a one sample mean t-test, and then we compared two sample and tested the means. And now we can actually do more than that. So we can do, you could actually do this one-way analysis of variance and compare the two sample means test. But this one is typically used when you have three or more means that you're testing. And uh, we want to start out again with, making sure that you review the week 6 discussion resources, and you read the chapter, and uh, that you have looked at, what this is, and you'll see there's a lot of similarities from all the other hypothesis tests, like the test statistic and the p-value and significance level, and so on. And so it says here, everyone will be testing to see if three or more means are statistically equal. And you have to search the internet to find a field of study appropriate. So we're very much just like what your other discussions that you had done. Um, you had to go out and do a little bit of research first, and then here, just again, note, we're not using rates or percentages or proportions. You need quantitative data, and you're going to list the numeric values, okay, in your table. And let's look at an example here. So it says calcium is an essential mineral that regulates the heart, important for blood clotting, for building healthy bones. So this National Osteoporosis Foundation recommends a daily calcium intake 1,000 to 1,200 milligrams a day for adult men and women. While calcium is contained in some foods, most adults do not get enough in their diets and take supplements. Okay. So again, we're focusing here on the amount. Again, that's a quantitative variable, but we're focusing on some measurable amount of, in this case, it was milligrams per day. And it says, unfortunately, some of the supplements have side effects. Gastric distress, making them difficult for patients on a regular basis. Okay, so a study is designed to see whether there's a difference in the average daily calcium intake, or mean daily calcium intake, in adults with normal bone density, adults with a osteopenia, low bone density, which may lead to osteoporosis, in adults with osteoporosis. Okay, so adults 60 years of age. So we're again just narrowing our population that we want to relate back to when we're done with all of this. We're talking about, right, 60 years with normal bone density, and these different three groups selected at random from hospital records invited to participate in the study. Okay. So this again is fairly typical of the types of things that you can do, but again, uh, there's a lot of different even types of analysis of variances that you can run. This is just a one particular one. When we say one way, what we're looking at is one categorical variable that we're dealing with, okay? And so that's not the calcium numbers in here. When we say a one-way, we're saying here, in this case, type of bone density, and they have that classified into what they would say, normal bone density is. And again, I don't know what the difference is between when you say normal and then this here and then the osteoporosis. So is there a statistically significant difference in the mean calcium intake in patients within these three groups? Okay. So for each group, again, we randomly selected 6 patients that had normal bone density, 6 patients that had this, and 6 patients here. And we're going to start out and say the null hypothesis is that the mean of this set of data here and the mean of this set of data and the mean of this set of data are all equal. Okay. So what I've set up here is, it's statistically equal, and what we mean by, because when we say equal, we're not really saying exactly the same. Like in arithmetic or mathematics or algebra or something, you may say two things are equal because they're exactly the same. And in reality, we know that they're not all going to come out exactly the same, but they would have to be statistically significantly different for us to, reject this. Okay, so basically we're saying that they're going to come out, the means are going to come out pretty close, right? What does that mean? Well, it depends on lots of things, but okay, so we have the null hypothesis. These are all equal. And the alternative hypothesis typically is that at least one of the means is significantly different from the other. You could have two of them, but for our purposes, we're going to write it is that the means are not all equal. They're all equal, they're not all equal. We're trying to keep it simple here. Significance level 5%, 1%. Usually that's all you typically see. So here's the information for the three groups. So this set of data values, there's the mean, right? 6 data values. This group here, there's 6, and then that's the mean for that group. And then this 6 here, that's our third group, and then there's so the statistic output, you'll notice it has some, a little more complicated, but as you go on in statistics, the test statistics and the outputs, kind of get more complicated. But this is the same idea. And when we talk about analysis of variance, we do use that in the computations, but we're really using the idea of these values, the differences between the groups, comparing to the differences within the groups. And that's what this treatment and error. And if you notice, basically you take this number divided by this number, you'll get that number. This number divided by this number, you'll get that number. And then this number divided by this number, you get the test statistic. Okay. And then critical value is a table value, and then you get your p-value just like for all the other hypothesis tests. So the only thing you have to remember is if the p-value is less than the significance level. So here, this p-value of 0.27 or 0.28 rounded is not less than this. So we would accept the null hypothesis in this case here, right? So now the rest of this is pretty straightforward. When you do your discussions, remember that you need to have something that has kind of accepted groupings, okay? Like you can't just say, well, I'm going to say age, then I'm going to create my own age group. So I'm going to say from 10 to 20 and 20 to 30. That's not accepted as the ages that would be the best way to breakup age. It's just somebody's opinion. Normal bone density has been defined by the medical community. This has been defined what that means, and these things are all well defined, separate groups, so we would know who goes in where, and there wouldn't be any argument, or at least there shouldn't be, in your grouping. So, and again, some groupings are very clear that they're groupings. Favorite ice cream, vanilla, chocolate, strawberry. You pretty much everybody would agree what's chocolate ice cream, what's vanilla ice cream, what's strawberry ice cream. Those are, clear groupings. So we want to have independent groups, okay, for this, and they have to be related. So this variable has to be one variable. These are not variables here. These are groupings, right? These are just categories. The variable is type of bone density. There are 3 different types of bone density shown here. And then we measured the calcium within those groups, okay? So you got to create your groups and measure them all on exactly the same thing, and you'll get your numbers. And then you got to, your hypotheses are all going to be exactly the same. Exactly the same here. And then you got to do your table here with your means. You put your information in the stat disk, and you'll get your output and draw your conclusion. So you should be pretty comfortable with the situation. And we've done a number of these so far. So let's go ahead and move this over. And I'll get stat disk over here online. So and we need 3 groups. And again, this information would go in here, right? So 1200, 1000, 980, 900, and it'll take me a minute here to get these in. 100. Okay. $800, $500, and $700. Okay, and then group 3, I'm going to put those in. 890, 650, and so if I get these all typed in correctly, right? So there's my groups, column 1, 2, and 3. I'm going to go to analysis. One-way analysis of variance, right? That's what we're doing here. Significance level, again, typically it's 5%, 1%. Now, number of categories for the row, right? That says 2. Whoops, clicked on the wrong one. Try that again. There it is. Okay. One-way analysis of variance. Select the columns. We had columns 1, 2, and 3. Right, 1, 2, and 3 here. And let's evaluate that. And then there's our output. And so, again, this stuff you don't have to worry about. There's our test statistic, or p-value, right? That's kind of what you're focusing on right now. So yeah, that's really it. And again, we would conclude, like, we fail to reject, and we would say that the no real difference no real difference between these 2 groups, the means, the average of those 3 groups of calcium intake. So in general, we'd kind of think that, the calcium intake numbers, look, that's higher, that seems lower, that seems lower, but these numbers are not significantly different, statistically significantly different. So uh, we wouldn't be able to, say that there is something there in terms of this type of bone condition, right? Type of bone density that occurs. Okay, that's it.